Hi, welcome to Studio Systems. I'm going to just show you how to sort out a fault, a classic fault on these desks. I've just brought an oscillator into channel 11 here, and as you can see it's coming through on the mix great, but on channel 12, so I'll put that into 12, you'll see that as I plug it in it disappears. Now this is because the jack socket, the line input socket, is duff. Somebody's either put an oversized jack in there or something's happened to it, but anyway it's got to be replaced. Now these desks are quite tricky to get into. I'm going to show you how it's done. First of all, these perimeter screws, you need to take these out. Leave the ones under the bridge, they're okay. The ones under here as well. And once you've got those out, you need to get the desk on the floor on its on the strip along here on the edge. So I'll just turn it off. Yeah, what I did was I just left a couple of screws on, these top screws here, there and there, while I put the desk on the floor. So I can take these two off. Right, I've taken off all the screws and you'll see that the whole desk splits now in two. So we take off the earth strap, remembering to put that back on when you've finished. These two connectors, this is the AC in, and you'll notice the little lip on the edge of that connector, so make sure that goes back in under the lip there. This is the DC out. This is also very important to get back in the right way. There's a little lip on there, but also the bottom connector is plus 48, which is the orange wire, so that's a way of remembering. For those of you who are going to send the regulator board in to me for repair, this is it here. Take these four nuts and bolts off here, M3, and then this whole thing comes off. Watch it, there'll be a load of heat sink compound on the back of here, very messy, so put it into a carrier bag or something. And the usual fault with if you lose a plus or minus 17 volt rail, it's usually these bridge rectifiers here, one of these. If they're the old grey type, I'll just replace them anyway, the originals, and put these what they call glass passivated ones in. Under here, under these heat sinks, are the actual regulators. The Topaz 24 has got LM317s, and the Topaz 32 has got 388 LM388Ks, which are more expensive, I think about £10 each. They do go, but it's rare. But it's easy to damage these by creating a short. If you put this in the wrong way around, for instance, short these out, you probably blow them. You have to replace both of those. It's a bit tricky. You have to basically take the transistors off. I'm not going to do it on this particular video, but those two go. The 48 volts rail is dependent on the plus 17. So if you've got 48 volt problems, suspect something around here. Sometimes you get dry joints on the bottom of these bridges here. Never had to change these caps, but you know the desks are getting old. There's your regulator for the 48, but as I said, it is slaved off the plus 17, so it's dependent on the plus 17. I've had some fun and games with these desks, I'll tell you. Anyway, so you pull this out, this whole tray, move that out of the way. Now, my problem was the channel 12 was the jack socket input. As you can see, we've got these preamp boards. This is where all the first stage of amplification is. And we cancel on 1 to 8, 9 to 16, 17 to 24, 25 to 32 up there. I need to get this board out. By the way, if you're getting problems with the Topaz, you can swap out these boards just to narrow down to see if the fault is on this main board, which is unlikely, or on this front end board, because obviously all the jacks and XLRs are on here. It's usually this board's a problem. One of the big problems is there's some protect diodes on the front end of these boards. As you can see them, they're in there. There's 4 diodes just on top of there, see them? Now these can go open, and the reason that is sometimes people plug in a synth or something on the mic input and those can blow those diodes. They're just 1N1041 diodes, but what happens when they blow, they go DC on both sides of the of the diode, and that will screw up your op amps, so they do need to be changed. The normal symptoms are very fuzzy, noisy input, you know, like chip frying sound, but it's usually those. You can check it with your meter. If you put your meter on both sides of this diode relative to reference to ground, you should only see rail volts on one side. If you see it on both sides, then they are leaky, okay, and you need to replace. So you can, if you want to be a real soldier, it's being channel 12. So I'm going to stop the video now and take the board out. As you can see, the way they come out, these little things just unscrew and come out, and then you've got two screws on the mic input as well. So the whole lot has to come off to get to that jack socket. Bit of a fiddle, but I'm just finishing taking these off. As you can see, it's a question of getting these little self-tappers out. Yeah, put them all in a little bin or something, because you don't want to be losing the socket, the jack socket collars, because I haven't got any more of these, and they do come off, these little collar things. I haven't got any of these left. Right, the way the collars come off, I didn't explain properly, but they just basically need a half turn. If you get some big cut on hand. As you see, the whole board's come out then, and we're interested in these sockets. Remember, this is 9 to 16, so it's 9, 10, 11, 12. I think this is the problem. We need to put a new one of these sockets in. So I'm going to just take off these two ribbons here, and then I'll put that on the workshop, and I'll show you in a minute how I'd change a socket. It's a good idea just to double check that it is the socket. I've done a little test here. If you just stick a stereo jack socket in, just always go for the one you know works, which is, I'll put that in 11. Okay, and just run your continuity meter around here, and if you locate the back of the jack here, so that's 9, 10, 11, as you can see, that's getting round, that's the tip, so that's getting to the jack socket, that's good. And then you can put it on the ring as well, because sometimes you just get either the ring or the tip's gone. And 9, 10, 11, just sniff that out, there it is there. So you've got that's the ring, that's the tip. Now put that onto 12. So that's into 12, which is one of the problems with. There's no ring on there. It's just on the ring at the moment. There's no. Yeah, the ring is good. That's right. But let's move that onto the tip. So our continuity meter's on the tip now, and there's nothing there. That should be continuity between that point there and the tip of the jack. I've just noticed there's a little tick on there, so somebody's been in here before. There's a cross on the next socket down, which is the insert, so it's all a bit confusing. Looks like that insert's been replaced, I'm not sure, but somebody's been messing around with this, so I'm going to take this socket off now. Now these are quite difficult to get out. I was only resting that in the vise there. Quite tricky to get out. Often when I'm trying to get a component or a socket or something out of a board, it's a good idea to, I can't demonstrate because I've only got one hand here, but when you've got your solder braid and your soldering iron, if you put the braid actually on the solder points, for instance here, and as you bring your soldering iron on, you need a good soldering iron, put a bit of if I see that, just put a bit of new solder on there, and that tends to get the heat distributing, and it pulls it out of the hole. So I can't demonstrate this because I've only got I've got a camera stand here. I shouldn't know really, but anyway. So you use a bit of fresh solder with the soldering iron, and that will suck out all of the old solder, and then you'll be able to drop that socket out. Okay, just a little tip there. Anyway, back in a minute. Right, so there's the old socket. Put it well away, because in the past I've gone and replaced the new one with the old one. This is a good move. Anyway, so as you can see, if I hold that up to the light, you've got some good holes there. You need to have those completely clean. So you can, if you use your solder braid to clean up the area. This is the solder braid, by the way. It's called the solder wick. You can get thinner bits than this. They come in different gauges. But when you, it's difficult to show you, but basically you can run the soldering iron on the back of the wick and clean all the area up like that. Okay. If you can see that, I think, yeah. Right, I'm going to put the new socket in now. I want one of them, one of them Google glasses. They only go one way around, so drop that in. Like that. Now you need to apply some pressure on this side so that it's tight into the socket there. Okay, so socket, it was actually the print through. The hot or tip of the jack would have gone to that contact there. The print through on the back, which will be connecting to the actual pin, has come away. I've only just noticed that somebody's had this out before, but that actually goes to this point here. So all we have to do is overlay a bit of tin copper wire from the socket pin to that point there. If you can see that, and then all will be well. I'm going to do that now. Right, as you can see, I put a little bit of mod wire. This is the tip of the jack socket, and that goes onto the PCB. That'll go to the amplifier, first stage of the amp. So a little bit of mod wire on there. Now I'm going to just double check that it is okay. So I come around and I put my jack plug in the socket there, and I've got my continuity meter, and I'll just buzz out onto there, and there it's good there. Okay, so I know that's getting through. With these topazes, check everything and then check it again, because they're a pain in the neck if you put it all back together again. It's sort of fault. So putting that on the ring, because this is balanced input, remember. Look for the ring, I think is there, is it? No, there. Oh, there's the ring. So I believe that to be repaired. I'm going to put it back on the desk, which is over there, and let's keep it. Okay, I put the board back in there, put the ribbons on, and I've just put a couple of screws on the XLRs. You've got to get that socket back in symmetrical, or you won't get these collars back on. I've just put a couple of collars on. I put my signal back in, my oscillator, onto 12. That's 8, 9, 10, 11, 12. Now, as you can see, it's always tricky these desks to work on live. I've reconnected the power supply. Make sure you get those around the right way. Orange for the 48, yeah. Little lip on there. Now, without pulling the whole desk over to see if it's actually getting through, you can just sneakily look through there and you can see the left-right meter at the back of it. So I know it's working. So 12 is good now. Okay, as you can see, quite tricky desks to work on. If I get a real problem on these desks, you have to take off this power supply board and hang it off the ceiling with string. It's ridiculous to be able to power it up and get to, if you want to do some fault finding on a desk like this. As you can see, they're built to well, what's the right word? I'm not going to use the word cheap, but they basically remind me of the old SEC desks from 1980. I think they pioneered this kind of single board stuff, non-modular. Lovely desk until they go wrong. A bit like the Mackie and the Behringer, they're all built the same. So I hope that's helped. A few tips there. This is good wishes from Tim down in Cornwall, Studio Systems. Topaz project. Have fun. See you.